Virtual water trade refers to the hidden flow of water if food or other commodities are traded from one place to another. For instance, it takes 1,600 cubic meters of water on average to produce 1 metric ton of wheat. The precise volume can be more or less depending on climatic conditions and agricultural practice. Hoekstra and Chapagain have defined the virtual water content of a product as the volume of fresh water used to produce the product, measured at the place where the product was actually produced. It refers to the sum of the water use in the various steps of the production chain. Professor John Anthony Allan from King's College London and the School of Oriental and African Studies introduced the virtual water concept to support his argument that countries in the Middle East can save their scarce water resources by relying more on import of food. For his contributions he was awarded the 2008 Stockholm Water Prize. Allan stated, "The water is said to be virtual because once the wheat is grown, the real water used to grow it is no longer actually contained in the wheat." The concept of virtual water helps us realize how much water is needed to produce different goods and services. In semi-arid and arid areas, knowing the virtual water value of a good or service can be useful towards determining how best to use the scarce water available. There are, however, significant deficiencies with the concept of virtual water that mean there is a significant risk in relying on these measures to guide policy conclusions. Accordingly, Australia's National Water Commission considers that the measurement of virtual water has little practical value in decision-making regarding the best allocation of scarce water resources. Virtual water trade. Virtual water trade refers to the idea that when goods and services are exchanged, so is virtual water. When a country imports 1 ton of wheat instead of producing it domestically, it is saving about 1,300 cubic meters of real indigenous water. If this country is water scarce, the water that is saved can be used towards other ends. If the exporting country is water scarce, however, it has exported 1,300 cubic meters of virtual water since the real water used to grow the wheat will no longer be available for other purposes. This has obvious strategic implications for countries that are water-constrained such as those found in the Southern African Development Community area. Water-scarce countries like Israel discourage the export of oranges precisely to prevent large quantities of water being exported to different parts of the world. In recent years, the concept of virtual water trade has gained weight both in the scientific as well as in the political debate. The notion of the concept is ambiguous. It changes between an analytical, descriptive concept and a political-induced strategy. As an analytical concept, virtual water trade represents an instrument which allows the identification and assessment of policy options not only in the scientific but also in the political discourse. As a politically induced strategy, the question is, whether virtual water trade can be implemented in a sustainable way, whether the implementation can be managed in a social, economical and ecological fashion, and for which countries the concept offers a meaningful option. The data that underlie the concept of virtual water can readily be used to construct water satellite accounts, and brought into economic models of international trade such as the GTAP Computable General Equilibrium Model. Such a model can be used to study the economic implications of changes in water supply or water policy, as well as the water resource implications of economic development and trade liberalization. In sum, virtual water trade allows a new, amplified perspective on water problems, in the framework of recent developments from a supply-oriented to a demand-oriented management of water resources. It opens up new fields of governance and facilitates a differentiation and balancing of different perspectives, basic conditions and interests. Analytically, the concept enables one to distinguish between global, regional and local levels and their linkages. This means that water resource problems have to be solved in problemsheds if they cannot be successfully addressed in the local or regional watershed. Virtual water trade can thus overcome the hydrocentricity of a narrow watershed view. According to the proceedings of a 2006 conference in Frankfurt, Germany, it seems reasonable to link the new concept with the approach of integrated water resources management. Limitations of the virtual water measure. Key shortcomings of virtual water measures are that the concept relies on an assumption that all sources of water, whether in the form of rainfall or provided through an irrigation system, are of equal value. implicitly assumes that water that would be released by reducing a high water use activity would necessarily be available for use in a less water-intensive activity. For example, the implicit assumption is that water used in rangeland beef production would be available to be used to produce an alternative, less water-intensive activity. As a practical matter, this may not be the case, nor might the alternatives be economic. Fails as an indicator of environmental harm, nor does it provide any indication of whether water resources are being used within sustainable extraction limits. The use of virtual water estimates therefore offer no guidance for policymakers seeking to ensure that environmental objectives are being met. The deficiencies with the concept of virtual water mean that there is a significant risk in relying on these measures to guide policy conclusions. Accordingly, Australia's National Water Commission considers that the measurement of virtual water has little practical value in decision-making regarding the best allocation of scarce water resources. Other limitations more specific to the MENA region include, in MENA rural societies, farmers are by tradition politically influential and would prohibit new policies for water allocation. Reallocating the water resources adds a huge burden on the farmers, especially when a large portion of those farmers use their land for their own food consumption, which happens to be their only source of food supply. Importing food could pose the risk of further political dependence. The notion of self-sufficiency has always been the pride of the MENA region. The use of virtual water lies in the religious regulations for charging for water. According to al-Bukhari, Prophet Muhammad unregistered trademark teachings, the Prophet said, OE people are partners in 3, water, herbs and euro. Therefore, and because farmers are generally poor and rainwater, rivers and lakes are like a gift from God, the MENA countries might find it difficult to charge the farmers the full cost for water. Water footprint. The concept of virtual water trade was introduced to refer to the idea that countries can save domestic water by importing food. Imported food, however, comes from somewhere. In 2002, Professor Arjen Y. Hoekstra, at the time working for UNESCO IHE, now at University of Twente, the Netherlands, introduced the concept of water footprint. The water footprint shows the link between consumer goods or a consumption pattern and water use and pollution. Virtual water trade and water footprint can be seen as part of a bigger story, the globalization of water. Embodied energy. Some researchers have attempted to use the methods of energy analysis, which aim to produce embodied energy estimates, to derive virtual, or embodied water estimates. The virtual water content of some selected products. The following table shows the average virtual water content of some selected products for a number of selected countries. See also, peak water, water footprint, water management, deficit irrigation, water resource policy. References. Further reading, Hoekstra, A.Y. Virtual water trade. Proceedings of the International Expert Meeting on Virtual Water Trade Unregistered Trademark Value of Water Research Report Series No. 12, UNESCO IHE, Delft, the Netherlands, Chapagain, A.K. and Hoekstra, A.Y. The Global Component of Freshwater Demand and Supply, an Assessment of Virtual Water Flows Between Nations as a Result of Trade in Agricultural and Industrial Products. Water International 33, 1, 19-32. Hummel, D., T. Kludge, S. Lure, M. Hackliff. Virtual Water Trade. Documentation of an International Expert Workshop. July 3, 4, 2006. Frankfurt am Main. ISOE Materialiensoziale Ecology No. 24, Lenzen, M. B. Foran. An Input-Output Analysis of Australian Water Usage. Water Policy 3, 321 euro 340 doi, 10.1016 per second 1366-7017, 01, 00072-1. Lenzen, M. The Influence of Lifestyles on Environmental Pressure, Australian Bureau of Statistics, Commonwealth of Australia, Bowdona M., Lenzen M., Piavora S., Criagera M. Water Accounting in Australia. Ecological Economics 61, 650 euro 9 doi, 10.1016/J. Ecolekon. 2006.07.033. Zygmunt, J. Hidden Waters. London, Waterwise. External links, Virtual Water Poster. Educational poster on virtual water by the Food and Agriculture Organization of the United Nations, interview on exploring geopolitics. Water, its virtual form, national footprints in global economy, Arjun Hoekstra, graph showing virtual water imports and exports worldwide, from looming water crisis simply a management problem by Jonathan Chenoweth, New Scientist August 28, 2008, pages 28-32, Virtual Water Poster. Typographic poster series on virtual water and water footprints of nations, based on the research data of UNESCO IHE, Water Footprint Network, information on Virtual Water Union International Year of Fresh Water, Virtual Water Flow infographic. Highlights the globalization of virtual water flows, breaks down the activities of the top 5 net importers and exporters of virtual water.